Hello everyone, welcome to Chemazon-Complete Chemistry. So let us first discuss about the review of GATE 2025 chemistry paper. So it was more on a difficult side, you can say moderate to difficult size because जो every year जो questions पूछे जाते हैं उसके comparison में नए टाइप ऑफ क्वेश्चन पूछे गए थे जो नेट लेवल के क्वेश्चन होते हैं कुछ वैसे टाइप ऑफ क्वेश्चन पूछे गए थे स्पेशली इनऑर्गेनिक केमिस्ट्री में. So that is why the level of the paper was more on the difficult side. इसलिए आप देखोगे तो कट ऑफ भी इस बार कम आया, that is only 25 marks for general category. So without much ado, we'll start. So in this video, we are going to solve questions 11 to 20, that is part A. In the remaining videos, we will solve the remaining questions. So coming on to the first question, the phosphazine compound then acts as a super base. So what is the meaning of super base? Super base, you think of a normal Lewis base. What is the definition of a Lewis base? Any species that can donate electrons, that is a Lewis base. So in all these compounds, you have to find out which of the following is the strongest base. Okay, so which is the electron donor here? It is going to be the nitrogen atom. Okay, it will have the electron density or lone pair that it can donate. Okay, so now in which of the following cases you can see maximum electron density or nitrogen? Here you can see chlorine is electron withdrawing group, so this option is incorrect. Okay, D option also, if you see here there is this lone pair, okay, but that is not that much electron rich. Okay, so this is also weak base. Then if you see option C and option A, okay, option A also, if you see, it is not a very strong base, okay, as compared to option C. Option C, if you see here, there are 3 nitrogen atoms, okay, all are donating its electron density to nitrogen via resonance. Okay, so this is going to be our correct answer, that is option C. Option C is the super base. Okay, let us see the next question, option 12. Question 12. Now, synthesis of Me2SiCl2 through Rorschach-Muller process. Now, this type of question is not asked before any time in GATE exam. So, you answer such questions only and only if you are sure. Okay. If you are not sure, don't answer such questions. Okay. It is for 1 mark. You will get a negative marking of minus 0.33. Okay. So what is the general theory behind this process? It is a reaction of methyl chloride with silicon in presence of copper as a catalyst and promoters at high temperature. So you will get hydrocarbons and you will get this trimethylsilyl chloride, you will get dimethylsilyl dichloride. This is the desired product, okay, that is Me2SiCl2. So what is a catalyst here? It is a copper, okay, it is not iron. So the correct answer is option C. So let us move on to the next question. Upon cooling from room temperature, the magnetic susceptibility of manganese slowly increases until 118 Kelvin and then it decreases. So you must know the plot, okay, where the magnetic susceptibility increases up till one temperature, that is they have given 118 Kelvin, and then it decreases. Okay. So you must know that this type of curve is seen in which magnetism. Okay, they don't expect you to memorize that manganese oxide will have which magnetic property. Okay, वो memorize नहीं करना है कि it will have so and so magnetic. You should know that this curve belong to which magnetism. Okay, so that is the curve of magnetic susceptibility and temperature. So as the temperature increases, you can see paramagnetic and ferromagnetic, it is exponentially decreasing curve like this. But for antiferromagnetic materials, you can see it is increasing up to one temperature, that is called as Tn, that is the Néel temperature, and then it decreases. Okay, it shows paramagnetic behavior. Okay, just like paramagnetic materials after Néel temperature. Okay, that is the exponentially decreasing curve. Okay, and what is Tc? Tc is a Curie temperature. Curie temperature is a temperature where paramagnetic materials lose their magnetism. Okay, ferromagnetic material also lose their magnetism. So what is the difference between Curie temperature and Néel temperature? Curie temperature, it is a temperature at or above certain material, they lose their magnetic properties. And Néel temperature is the one where antiferromagnetic material become paramagnetic. Okay, magnetic material become non-magnetic in case of Curie temperature, and antiferromagnetism becomes magnetism, paramagnetism in case of Néel temperature. This is named after Marie Curie. This is named after scientist Louis Néel. Curie temperature is represented as Tc, Néel temperature represented as Tn. What is the correct answer? Option C. Okay, let us move on to the next question. An aqueous solution of cobalt ClO4.6 H2O 42.6 H2O. This you add HCl and you will get some complex that is a having intense blue colored solution. So that is a hint. Okay. So do you have to remember this reaction? By heart this reaction? The answer is no. The hint that they've given is that it has an intense blue color. Okay. So instead of asking the intensity order, they have indirectly given you a hint that it is an intense blue colored solution. That is, it is having a good intensity. So that is seen for which complexes? That is seen for tetrahedral complexes. Why? They are very intensely colored complexes because in Laporte selection rule, it is Laporte partly allowed. Okay, Laporte partly allowed. That is, it has relaxation in the Laporte selection rule. That is why it is having intense colored complexes. Whereas in octahedral complexes, it is forbidden. Laporte forbidden as well as spin forbidden. Okay, so which is the tetrahedral complex? You can see that is 3. So the final answer here is CO, Cl, 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 overall charge 2 minus. So option answer is, correct answer is option C. Okay, now let us see the next question. For an unambiguous single step synthesis of the following target molecule. So this is a target molecule. What is the meaning of target molecule? Molecule that you want to synthesize or molecule to be synthesized. Okay, so basically what you have to do is you have to do fragmentation. Okay, or that process is called disconnection. Okay, this is the target molecule that is given, and now you have to perform a disconnection or breaking of a suitable bond. Now which bond you have to break? The one that you can easily form. Okay, ऐसा bond break करना है जो तुम form भी easily कर सकते हो. Okay, retro means reverse synthesis. Okay, reverse analysis करते हैं product to starting material, that is called retrosynthesis. Then you do forward synthesis, that is starting from starting material or reactant, you synthesize step by step, you synthesize the final molecule or the target molecule. So you know 6-membered ring is stable, so you breaking this would be a bad disconnection. Okay, so these two options are eliminated, A and D. Between B and C, you know this is a active methylene carbon. Okay, here if you form a negative charge, you can easily form the enolate. So that is why we will break this bond. Okay, like that. This is called as curvy disconnection arrow. Okay, disconnection arrow. Option C will be incorrect. Now we have to see how option B is the correct answer. So you break, and which is more electronegative? This is more electronegative, right? So minus will form here, and here you will get a plus charge. Plus charge minus CO2 ET, CO2 ET. So these are imaginary fragments, and these are called as what? These are called as synthons. Imaginary fragments are called as synthons. Okay, they do not exist, they are imaginary fragments. Now this fragment you can get it from some other molecule that is a starting material. They are called as synthetic equivalents. So from where you can get this negative charge? From the corresponding diester molecule. Okay, you add minus charge, you add what? You add hydrogen. So you will get one starting material is this. This is diethyl malonate. Okay, 3 carbon. Dicarboxylic acid is malonic acid. Plus, how you can get this? So suppose you have a alpha beta unsaturated ketone. Okay, so this can undergo resonance and you will get what? You will get an structure like this. So you can see here positive charge is forming. So which is a corresponding starting material? It is alpha beta unsaturated ketone. Okay, so these are the starting material. They are also called as synthetic equivalent. So how you do this synthesis? You add some base like sodium ethoxide. Okay, this will abstract this proton. You will get this enolate, and this enolate will undergo conjugate addition to this alpha beta unsaturated ketone to form the final target molecule. So what is the correct answer? Option B. Okay. Option 16. So what is the formula for splitting pattern? 2Ni plus 1. What is N? N is the number of nuclei. You have to find out the splitting pattern for HA. Now if you see the adjacent carbon, here it is forming 4 bonds. So there is 0 hydrogen. So suppose you substitute N, I for hydrogen it is half, N will be 0. So 2 into 0 plus 1, 1 singlet. If you mark answer as singlet, that will be incorrect. Why? Because you must know that deuterium, its atomic mass is 1, atomic number is also 1. So this is odd. Okay, that means it is what? NMR, active nuclei. So there are how many nuclei? 2 deuterium atoms. 2 into 2 into 1 plus 1. Okay, value of I, that is spin, for deuterium it is 1. So 2 to the 4 plus 1 5, that is going to be quintet. So the correct answer is option C. Okay, let us see the next question. A disaccharide X does not show mutarotation in aqueous solution. So what is the criteria for a molecule to show mutarotation? The criteria is at the anomeric carbon. So this is the anomeric carbon. What is the meaning of anomeric carbon? Anomeric carbon is carbon attached to 2 oxygen atoms. So this carbon, you can see it is attached to this oxygen atom as well as the other oxygen atom. So at the anomeric carbon, if there is free hydroxy group, then it can undergo ring flipping in aqueous solution. Okay, this is the beta, this is the alpha anomer, and you will get, after ring flipping, okay, you will get what? You will get the beta anomer. So this alpha has some optical rotation, beta has some optical rotation. So this will show mutarotation. So first we have to identify the anomeric carbon. Option A. Here this is the anomeric carbon and this is the anomeric carbon. Here if you see, the hydroxy is not free. Here also hydroxy is not free. So this will not show mutarotation. This can be the correct answer. Option B, if you see, here this is the anomeric carbon and this is the anomeric carbon. So here it is not free, but here you can see one hydroxy group is free. So this will show mutarotation. Option B is incorrect. Option C also, here you can see it is hydroxy group is free. Okay, so it will show mutarotation. Last option, here this is the anomeric carbon and here this is the anomeric carbon. So here also the anomeric or hydroxy group is not free. Here also it is not free. So this also will not show mutarotation. Option D can also be the correct answer. Now the hint that they have given is 2 different monosaccharide are formed. Now A, if you do hydrolysis means breaking this bond, adding hydrogen on oxygen, and other side you add OH. So if I do the numbering, you can see both are what? After hydrolysis, they both are the same molecule. Suppose this is carbon 1, here this is carbon 1, here hydroxy is below the plane, and this molecule you will invert and write. Okay, this molecule you will invert and write. So here also this is below the plane. Okay, invert, and then you will get the same structure like this. Okay, like that. Carbon 1 OH is below the plane, carbon 2 here it is below the plane, here also you will see it is below the plane, carbon 3 above, carbon 4 here it is below, here it is also below, 5 is also same. So these are what? These are two glucose molecules that you are getting. So this is not the correct answer. They have given it should form two different monosaccharides. This is the correct answer. It is sucrose. Okay, sucrose. Here it will form this six-membered pyranose, that is glucose, and this is fructose. So here the answer is option D. Okay, now let us see the next one. 18. The symmetry element that does not belong to C4V point group. So let us understand this with the example. C4V point group, let's say it is IF5. Okay, it has pentagonal, it has square pyramidal structure. Okay, so here if I draw an axis like this passing through this fluorine, okay, and I rotate this by 90 degrees 4 times, that is 360 divided by n, and n is what? 4. So I will get 90 degrees. Okay, so I will get the same molecule. So that means a C4 axis is present. One thing present is C4 axis. Now perpendicular to this C4 axis, you can see there is one this axis, one this C2 axis, one this C2 axis, and then this is C2 axis. So there are 4 C2 axes, 4 perpendicular C2 axis. Then along the same C2 axis you will have 4 sigma V planes. Okay, that is vertical plane of symmetry like this. Okay, I have drawn one. Similarly there will be 4, and last element of symmetry that all the molecule has, that is identity E, that is if you rotate the molecule by 360 degree you will get the same molecule. That is very logical. Okay, so what all are present? Which is C4 is present, C2 present, sigma V present. Which is not present? The answer is option C. So very important, you have to read the question. Okay, jaldi mein it is as does not, and you will quickly mark answer A, that C4 is present. So that will be incorrect. Okay, next question. Rigid rotor wave function. The two wave functions they have given, the for a non-polar diatomic molecule. Okay, the value of transition moment integral is. So this is the formula. Okay, I is equal to double integral psi star mu cos theta of the other wave function sin theta d theta d phi. So in this formula, so do you have to solve this double integral? The answer is no. This question is for 1 mark. Okay, you have to think logically. For 1 mark, no one is going to tell you to solve this. Okay, कोई भी solve करने नहीं बोलेगा ये question. Okay, ये बहुत बड़ा integral है and इतना बड़ा integral solve नहीं कर सकते. At least for 1 mark it is not possible. So you have to use some logic, that there will be some hint. What is that hint? Non-polar diatomic molecule. Okay, polar diatomic molecule दिया होता तो then you have to solve. But non-polar diatomic molecule, let's say H2, okay, or O2 or N2. For all these molecules, we know the dipole moment is what? 0. So this mu value is 0. Everything is multiplied. So what will be the value of I? It will be 0. So the correct answer here is option B. So देखने में ये बहुत difficult लगता है कि क्या दे दिया है. Okay, but if you know the at least ये formula पता होता, so then you can solve it easily. If you don't know the formula भी नहीं पता, so then you cannot solve, right? So the last question for this video, they have given three partition function. They depend on which thermodynamic variables? That is a question. Okay, so this Q trans is a translational partition function. You can see it depends on volume. It also depends on temperature. Okay, the translational depend on temperature and volume. This can be the answer. This can be answer. Option C, only temperature, incorrect. Option D, temperature volume. Okay, so one option is eliminated. So always use the method of elimination. So one by one you analyze, read the question carefully, and one by one you try to eliminate the option. That way it will become much easier for you to solve the question. Okay. Next, vibrational partition function. So it depends on temperature. Okay. Second one, temperature volume, incorrect. Only temperature, only temperature. So now only B and D are remaining. Now rotational partition function, you can see it depends only on temperature. So temperature volume, incorrect. The only correct answer is going to be option B. Okay. So this type of question, instead of giving all the values and giving you to substitute all the values, instead of that they have given, you must know the formula. Okay, for this also you must know the formula. If you don't know the formula, then you cannot solve. Okay, I hope you have understood all this solution. In the coming videos we will see the next solutions. Thank you.